Hello everybody, so this is my presentation of real-time EV ADAS dashboard. So I'm Asta Sinha, BTech second year student from 4th semester. So yeah, let's get started. So this is my STM32, the requirements, STM32. Um, then we have the C language, ADAS sensors, and then the live dashboard. Okay. So introduction. What is the real-time EV ADAS dashboard? So the first line itself clarifies that this project simulates the electronics inside a modern electric vehicle, reading live sensor data with an STM32 microcontroller and then display it on the real-time dashboard, which we'll see after the presentation. Okay, so and then it combines the ADAS using three ultrasonic sensors which is for the front, the left and the right of the vehicle. In the front, then we have in the left and the other one in the right. And then the EV parameters, which is the speed, battery torque and motor temperature. Then yeah, that is the STM32 blue pill. We have three ultrasonic sensors and then the live serial live dashboard. Okay, so yeah, basically it reads all the, it simulates, it basically uh, help us function. This project functions or implements all the electronics inside a modern electric vehicle using live sensor data with STM32 microcontroller. So with the help of STM32 microcontroller, it helps us read all the data of the modern electric vehicle and also helps us simulates. This project helps us simulates all the electronics inside the EV vehicle, inside the modern EV electric vehicle. Okay, so then we have the objectives. So we'll take a quick look. So we use an STM32 microcontroller to read multiple analog and digital signals in real time. Then we simulate EV parameters, that is for the speed, accelerator, brake, SOC and motor temperature using potentiometers. Okay, then we detect nearby objects on three sides, which is in the front, left and right using ultrasonic sensors. Then we implement basic ADAS logic. Now why we implement basic ADAS advanced driver assistant system logic is to detect the blind spot detection and time to collision warnings. Okay, then we stream all the live data to the UART to a virtual over UART to a IO virtual terminal, where we get all the data monitored on the UART. Then we visualize everything on the real-time dashboard. Next we have is the hardware components, where we have the STM32 blue pill, 4 potentiometers, 3 ultrasonic sensors, 4 potentiometers. We have the accelerator, the brake, the SOC and the motor temperature. The 3 sensors for the front, the left and the right. Then we have the LEDs, red for the collision, green and navy for blind spot detections, yellow for the warning. Then we have the buzzer. Then we have the buzzer. We have basically the audible alarms for collision, for the critical alarm and the advisory alarm. Then we have the UART, where everything is being displayed over UART and on in a virtual terminal, which is the IO virtual terminal and the dashboard. Then we have the software tools, which is the embedded C. Then we have the software tools, that is firmware written entirely in C, flashed onto the STM32 microcontrollers. Then it handles ADC reads, which is the potentiometers, that is every single thing, the brake, the accelerator, the SOC, the motor temperature, everything. And then the LEDs, buzzers, which is the GPIO controls and timers for ultrasonic echo timing. It implements the ADAS logic, threshold, time to collision and alarm levels. It sends formatted data frames, speed, SOC, torque, etc. over UART every cycle. Then simulation and visualization, which is quite clear here in PICSimLab, how it simulates the STM32 board, potentiometer, sensors, LEDs and buzzer virtually. Then we have the virtual terminal, how it displays the live UART data stream for testing and debugging. Then in the PC dashboard, how graphical app it reads all the serial data from the UART, and we get all the bird's eye view, basically the time to collision and the blind spot detections, bird's eye ADAS view by using the ADAS logic. Yeah. And then we have the system block diagram. So STM32 blue pill is basically the heart of the entire project, how everything is being operated uh, over that, and how it helps us process everything in the modern electric vehicle, and what are the uh, things we basically use. The four potentiometers, accelerator, brake, SOC, temperature, ultrasonic sensor, front, left and right, LED indicators, buzzer, our virtual terminal, and then the dashboard, live dashboard. Then we have is the input sensing of the potentiometers. On the potentiometers, as I said, we have the accelerator pedal, brake pedal, state of charge, the SOC, motor temperature, and how we uh, how the how we read all the things on the potentiometers. Then we have the ultrasonic sensing and ADAS, front, left and right coverage for collision and blind spot awareness. Front basically is for the time to collision and the collision flag, left is for the blind spot detection and right is for the right blind spot detection. Time to collision sends until seconds until impact at current speed and distance. Collision set when an obstacle is critically close ahead. We'll get the red the alarm will start getting critical, so we'll get the red LED will start glowing. Then we have the blind spot detection, left and right, warns of object besides the vehicle. It gives the warnings which is the besides the vehicle, which is maybe in the left or in the right obstacles. Then we have the alarm. Yeah. Then we have the output system, the LED indicators, buzzer, virtual terminal, and then the dashboard. Okay. Now 10. Now this is the system workflow, which is how it reads the sensors, then processes in C, then how it drives the output, then how it sends the data. After the output, how it sends the data over the UART into the IO virtual terminal, and everything is being monitored there. And then how it gets visualized on the live dashboard. Then we have the behavior logic, what happens when accelerator increases, brake pedal increases, SOC decreases and speed decreases. So everything is being mentioned here. Yeah, so this is the preview of the dashboard. So here this is the front ultrasonic, left, this is the right, this is the time to collision is almost 0.0, the alarm is critical, we can see this, which is this is the bird's eye view using the DAS logic. This is the blind spot detection, and yeah, this is the speed, this is torque is 0, acceleration 42, brake 0, motor temperature 40.2. So these are the key takeaways. One thing I wanted to focus on, this is C. This is the continuous loop, that is it reads, it processes, and then we get the output, then it sends the data, then it gets visualized on the dashboard. First it reads, then it gets processed in C language, then we get the output, then it sends it to the UART on the IO virtual terminal, and then it gets visualized, and yeah, and then it keeps on repeating. So that's why it's a continuous loop. So yeah, I think it's quite pretty clear, and this is, yeah, that's it. Now let's take a look. So this is my main project, that is EV dash. Yeah, so this is my main project, this is main.c, and here all my projects are there, that is ADC test, blink, and then EV dash, we have ultrasonic sensors, LED blink, timer. So yeah, let's open the PICSimLab and we'll see. So I was just doing a demo, so I'll just see the, let's see the project once. Yeah, so we are getting alarm, critical alarm, but let me just reset it. Just get the output. Yeah, so it's getting increased, speed is getting increased. Now we can see that. Yeah, now we're gonna get, so yeah, if I'll increase the acceleration, the speed will increase, but if I'll increase the brake, the state of charge is gonna decrease. Okay, so if the brake is at 0, the state of charge gonna increase. So brake is at 0, this is the motor temperature. I'll get, and this is the SOC. So let's see now if I'm getting that. Yeah, see, I'm getting critical alarm. Okay, you can see now, this is the right, this is the left, this is the front. Time to collision. There's a lot of variation in the graph, so yeah, let's see. I'll get, so this is the right, the navy is the right blind spot detection, and this is the left blind spot detection. So yeah, we are gonna see, we are getting, yeah, see, it's quite obvious. We can see this now. So yeah, I'll just decrease machine a little bit, increase. To run it once again, just again. Yeah, you can see here we're getting the, all the things, speed is increasing. See, acceleration is 51. Here no fault, like there's nothing, fault is 0, alarm is 0, as we are not getting any alarm right now. The sensors are increased. So yeah, you can see that. Yeah. Speed is increasing. See, all are glowing. This is the critical, this is the left blind spot detection, this is the right blind spot detection, and this is the advisory alarm. Okay, see, everything we can see it here. The acceleration is 51, brake, motor temperature, alarm, everything, fault, signal, front ultrasonic sensor, left ultrasonic sensor, and then the right ultrasonic sensor. Yeah, yeah, see, I'm gonna increase this all. Yeah, sorry, we're getting everything here, it's being shown very very clearly. Yeah, see, speed is increasing now. It is, yeah, we can see that. But we are gonna increase, and we are gonna get the advisory alarm now. See, yeah, speed is 85, acceleration 51 now, torque is 0, SOC 99. Let's see the dashboard. Yeah, just a second, we're getting advisory alarm, right? I'm just trying to just load the binary file. Yeah. Speed is being constant. I guess so. Yeah. Thing is, I'll get the critical one. Yeah. I'm gonna decrease the acceleration. Let's increase the SOC a little bit. I increase this, and I'm gonna increase this as well, which is the front ultrasonic sensor. Okay, so now the speed is increasing. It will increase, yeah. So that's it for my project. This was my live EV ADAS dashboard project. So yeah, this was a very fruitful uh, learning experience for me. Thank you so much.